Next, we're going to take a look at the fundamentals of building a smart application. Before you ever open the SensiML Toolkit, let's take a moment to think about the problem we are trying to solve. We need to build a smart algorithm that fits on a low-powered device. The SensiML Toolkit takes a train-by-example approach to do this. This approach can be broken down into 3 steps: collecting your training data, creating a model, and validating your results. Let's think more about our first step, collecting our training data for a new application. What are the types of events we can detect? Detecting events is the main goal of the SensiML Knowledge Pack. Applications typically fall into 2 categories: continuous events and discrete events. Continuous events are events that happen over longer, gradual periods of time. Think of them like you're looking for the current status of the device. An example of this includes a motor status sensor. In this example, the sensor will detect a normal, warning, or critical failure status. Another example is a fitness wearable device. You may be looking for the user's activity status: running, walking, or resting. Discrete events are events that have discrete trigger actions that the application needs to be trained for. An example of this is a wearable gesture device, where the user makes a specific gesture with their hand: A, D, L, M, or U. If we look back at the fitness wearable application above, instead of the continuous status, running, walking, or resting, we may look at each footstep as a trigger event. Why is this important? The type of event you are trying to detect will change the way you want to train your raw sensor data in the SensiML Toolkit. We will go into this concept in more detail later in the tutorials. Next, let's take a look at metadata. Metadata are custom properties that you can save to your files when you upload them to the SensiML servers. Metadata properties are normally attributes about the subject or object you are recording. This is a very important feature. Let's go over how this is useful. Grouping events by category. If you are building a motor fault detection application, you can save the motor size of the motor you are recording. When you start to build your application, you might find out that you need 2 models to get accurate results: a small motor model and a large motor model. Since you save the motor size as metadata, you can easily split these models. Filtering events by ID. You could save the subject ID or motor ID as metadata. Saving an ID with each file allows you to ignore certain subjects or objects. If you find that their data was not recorded correctly, or maybe one subject or object is an extreme outlier from the rest of your data.